Most aircraft have only one body. The nose, cockpit, wings, and tail are arranged along a clear central axis. From early biplanes made of wood and fabric to today's jet airliners, this has become the image of aircraft we are most familiar with. But in the history of flight, there is another path that is rarely mentioned. Some aircraft have two bodies. They look like two aircraft placed side by side, then connected by a section of wing. Some have cockpits on both sides. Some can only carry people on one side. Some were built to tow enormous gliders. Some were built to help pilots endure extremely long flights. And some were built to leave a large enough space between the two fuselages. This path never became mainstream. It looks heavy, strange, and even somewhat unnatural. But whenever a conventional aircraft could not complete a certain task, the twin-fuselage aircraft would briefly appear. It was like a direct and rough answer given by engineers facing an extreme problem. If one plane was not enough, add another one. In this episode, we will look at a brief history of twin-fuselage aircraft. Today, twin-fuselage aircraft look like a very strange kind of design. They do not match most people's instinctive idea of what an aircraft should be. Modern aircraft almost all share the same basic shape: one fuselage, wings on both sides, and a tail at the back. But in the first decades of the 20th century, aircraft were not like that. Flying machines of that era were more like an experiment that had not yet ended. Humanity had only just learned how to leave the ground, and no one really knew what an aircraft was supposed to look like. Some believed that the more wings an aircraft had, the better. Some placed the engine in the front. Others put the propeller at the back. Some aircraft looked like kites, some looked like wooden boats, and some did not even look as if they could fly at all. The twin-fuselage aircraft appeared during this chaotic period. Many of the earliest twin-fuselage aircraft were connected to water. In those days, an airport itself was a luxury. Many aircraft did not take off from runways, but directly from the sea, lakes, or harbors. In 1913, a very strange flying machine appeared in Britain, the Radley England waterplane. It had two hulls arranged side by side. The pilot and passenger sat separately on the left and right sides, while the wing structure in the middle connected the two bodies. From today's perspective, it already looked very close to what would later be called a twin-fuselage aircraft. But it was more like a flying catamaran. People of that era were still trying to understand aircraft through the logic of boats. The aircraft that was closer to the modern idea of a twin-fuselage aircraft appeared 2 years later, also in Britain. It was the 1915 Blackburn TB, later remembered by its far more famous nickname, the Twin Blackburn. This aircraft had two truly separate fuselages. The pilot sat on the left, the observer sat on the right, and each side had its own engine. Interestingly, there was no radio communication between the two crew members. In the huge noise of the engines, they could not even hear each other speak. Much of the time, they could only communicate by waving. From a modern perspective, this layout was very strange. It added weight, drag, and structural complexity. But in that era, humanity had not yet found the standard answer for aircraft design. Everyone was experimenting, and the twin-fuselage aircraft was simply one of the paths that looks most surprising to us today. By the 1920s, twin-fuselage aircraft even began to appear somewhat mature. In 1924, an extremely famous twin-hull flying boat appeared in Italy, the Savoia Marchetti S.55. The Savoia Marchetti S.55 had two long, slender hulls. The cockpit was located inside the central wing structure, while the engines were placed directly above the wing. The whole aircraft looked like some kind of mechanical creature from another era. But what truly made it famous was not its appearance, it was the fact that it was genuinely successful. The S.55 completed large-scale long-distance formation flights over the ocean and even crossed the Atlantic. In New York in 1933, 24 S.55s arrived like a shadow covering the sky. This was not only a miracle in aviation history, but also the most glorious moment of the twin-fuselage layout. In an era when many aircraft could still only fly slowly along coastlines, it almost looked like a technology from the future. It showed that twin-fuselage aircraft were not merely failed odd designs. At least for a time, they seriously competed in the race to define the aircraft of the future. Because in that era, aircraft had not yet converged into the forms we know today. They were more like rapidly evolving organisms, growing all kinds of strange shapes. And what truly pushed twin-fuselage aircraft in a different direction was the rapidly expanding World War that came next. The term twin-fuselage aircraft sounds simple at first, two airplanes joined together. But once you actually step into aviation history, you quickly realize that things are not that straightforward. Many aircraft look like twin-fuselage aircraft, but actually are not. Meanwhile, some aircraft have only a single cockpit and are still considered true twin-fuselage designs. The key is not how many pilots the aircraft has. The real question is, does the aircraft truly possess two bodies? During World War II, Germany proposed an extremely unusual aircraft project, the Messerschmitt Bf-109Z. The Z came from the German word Zwilling, meaning twins. The logic behind it was very direct. If a single Bf-109 was already approaching its performance limit, then why not combine two together? 1 plus 1 might not equal 2, but it would certainly be greater than 1. So two Bf-109s were connected by a shared center wing section. The left fuselage retained the cockpit, while the right side was sealed off. It never truly entered service, but it came very close to what people imagine as a classic twin-fuselage aircraft. The Italian-designed Savoia Marchetti SM.92 used a very similar layout. The cockpit was placed on one side, while the other side was mainly used for weapons and structural support. Both of these aircraft are considered twin-fuselage aircraft because both sides are true fuselage structures, not simply engine pods. This distinction is important because many famous aircraft are often mistaken for twin-fuselage designs. The most famous example is the Lockheed P-38 Lightning. The P-38 looks very much like a twin-fuselage aircraft. Its left and right sides are separated with a small cockpit in the middle, but in reality, it belongs to a completely different category, the twin-boom layout. The true fuselage is actually located in the center, while the structures on both sides mainly contain the engines and tail booms. Germany's Focke-Wulf FW-189 Juhu is another similar example. It resembles a twin-fuselage aircraft at first glance, but it does not truly possess two bodies. It should also be said that twin-fuselage aircraft are not an especially efficient design. Most of the time, they are heavier, more complex, and more difficult to control. So whenever such a design appears, it usually means that ordinary aircraft are no longer capable of solving a certain problem. And sometimes, engineers push this logic to an almost absurd extreme. One example is the Rutan Model 202 Boomerang by American designer Burt Rutan, a true cult aircraft in aviation history. This aircraft is even asymmetrical. The left and right sides are not the same length. It looks like an airplane that is flying crooked. But the reason behind it is very practical. When a twin-engine aircraft loses one engine, the aircraft can violently yaw to one side. The Boomerang's asymmetrical structure was designed to keep it stable even after a single engine failure. In other words, the Boomerang completely changed the normal shape of the aircraft in order to deal with a low probability but potentially deadly situation. The logic behind it may seem strange, but it perfectly demonstrates one thing. Twin-fuselage aircraft were never an aesthetic choice. They were extreme answers created by engineers facing extreme problems. By the time of the Second World War, aircraft were becoming larger and larger. Bigger bombs, longer range, more fuel, and more engines. As the scale of the war rapidly expanded, a new problem began to appear. Some missions had already exceeded the capability of a single aircraft, and so twin-fuselage aircraft entered their true peak period. In 1941, Germany created an aircraft that still looks outrageous today, the Henkel H111Z. Z once again came from the word Zwilling. In essence, it was simply two Henkel H-111 bombers forcibly joined together. A new center wing section was added, along with an extra engine. The result was an aircraft with 5 engines, 2 fuselages, and a wingspan of over 35 meters. The reason for its existence was very simple. Germany needed to tow a gigantic transport glider, known as the Me-321 Gigant. But ordinary transport aircraft simply could not pull something that massive. So in the end, they decided if one aircraft was not enough, then turn 2 aircraft into 1. The entire structure of the H-111Z carried a very obvious sense of engineering brutality. But it worked. At the same time, the Americans pushed the twin-fuselage concept in a completely different direction. The 1945 North American F-82 twin Mustang looked like 2 P-51 Mustangs connected side by side. But it was not a crude improvisation. It was a truly mass-produced twin-fuselage fighter that actually entered combat service. The reason behind its creation was also extremely practical. By the late war years, American bombers were flying farther and farther, from Pacific Islands to Japan and from Britain deep into Germany. But the problem was that although fighters could technically reach the target area, the pilots could not endure the journey. Long flights caused fatigue, reduced concentration, and sometimes even impaired judgment. The F-82's twin fuselage layout gave pilots more room. 2 pilots could take turns flying and even rest during long-range missions. For the first time, the twin fuselage structure was no longer only about carrying more weight, it was about going farther. And because of that, the idea of twin fuselage aircraft did not disappear with the end of the propeller era. In the jet age, some designers even tried to continue this logic. One of the most representative examples was the F-104 GTR twin starfighter. It was a twin fuselage concept based on the F-104 starfighter. The idea sounded very familiar. Connect 2 F-104s side by side and turn them into a long-range escort fighter with greater mission capability. In some ways, it was like a jet-age version of the twin Mustang. But this time, the aircraft was no longer a piston-engine fighter. It was a slender, sharp, extremely fast jet aircraft.
This concept never became reality. As the jet age arrived, people quickly realized that the cost of 1 + 1 was simply too high. 2 fuselages meant greater drag and far more structural complexity. And once a single turbojet engine had enough thrust to push an aircraft beyond the sound barrier, the old idea of joining 2 airplanes together gradually began to lose its purpose. Aerial refueling, long-range missiles, and new tactical systems soon replaced the concept of the twin fuselage escort fighter. And once again, twin fuselage aircraft retreated to the edge of the aviation industry.
The twin fuselage aircraft of this era often feel like temporary solutions created for extreme situations. They appear for a moment, only to be replaced very quickly by more mature technologies.
After the Second World War, the jet age arrived quickly. Aircraft became faster and faster. Swept wings, slender fuselages, and streamlined forms gradually pushed aviation into a highly converged state. By the second half of the 20th century, most aircraft were beginning to look increasingly similar. Humanity had finally found a relatively efficient, stable, and standardized aircraft layout. Twin fuselage aircraft, meanwhile, once again became a niche path, but they never truly disappeared. Over the following decades, their presence continued to appear from time to time in various projects and concepts. And what eventually pulled them back out of the blueprint stage was the fact that humanity once again encountered tasks that a single aircraft simply could not handle. After the war, the United States proposed an extremely ambitious concept known as the Twin-Fuselage C-5 Galaxy.
In simple terms, the idea was to connect 2 C-5 Galaxy transport aircraft together. The purpose was very direct: to carry extremely large cargo, such as the Space Shuttle. Conventional cargo aircraft are always limited by the width of their fuselage. But the twin-fuselage layout is different. It can create an enormous central area between the two bodies. The ultimate expression of this idea may have been the Antonov AKS concept proposed in the late 1980s. It was not an ordinary AN-225. Instead, it envisioned connecting two AN-225 fuselages together to form a gigantic twin-fuselage airborne launch platform. Suspended beneath its raised central wing section would have been a massive spaceplane. Antonov wanted the aircraft itself to become part of the rocket launch system. With the collapse of the Soviet Union, the project never made it beyond the drawing board. But the idea of using twin-fuselage aircraft as airborne launch platforms did not disappear. Entering the 21st century, humanity finally turned this concept into reality. And the person who took that step was the American designer we mentioned earlier, Burt Rutan.
In 2002, the White Knight was born. It used a modern twin-fuselage structure. Suspended between the two fuselages was Spaceship One, the private spacecraft that later became famous around the world. Unlike earlier twin-fuselage aircraft that looked like two aeroplanes stitched together, the entire structure of the White Knight was designed almost entirely around the central payload area. Its operating method was simple. First, the White Knight carried the spacecraft to high altitude. Then it released it. Finally, the spacecraft ignited its own rocket engine and accelerated further. The greatest advantage of this method was that it avoided the most fuel-intensive phase of rocket flight near the ground. And the aircraft that truly made this modern twin-fuselage structure widely recognized was the later White Knight II. Built for commercial human spaceflight, White Knight II was significantly enlarged. The aircraft looked almost like a gigantic flying gateway suspended in the sky. By 2019, humanity had created the aircraft with the largest wingspan ever built, the Stratolaunch Rock. The Stratolaunch Rock had 6 engines, a wingspan of 117 meters, and 2 complete fuselages. From a distance, it looked almost like 2 giant airliners forcibly joined together.
It is used for testing hypersonic vehicles and airborne launch systems.
From giant gliders to spacecraft and eventually to hypersonic vehicles, increasingly large and increasingly specialized machines have once again brought humanity back to the twin-fuselage aircraft.
Twin-fuselage aircraft never became the main characters of aviation history. They are more like the special mercenaries of the aerospace industry. Whenever humanity wants to fly farther than the limits allow, or carry something heavier than conventional aircraft were designed for, we end up returning to this 100-year-old piece of brutal engineering logic. And perhaps that is what twin-fuselage aircraft really remind us of. Beyond the pursuit of absolute efficiency, sometimes the simplest and most brutal form of addition can become the shortest path toward the stars. This is BHE, Brief History of Everything.